Rzekłem na konferencji Mars Society, czy jesteśmy sami w
my
kosmosie.
mathematical brain, the numbers alone make thinking about aliens perfectly rational. Well, how things have changed. I've known Stephen Hawking since 1970 when I was a postdoc at the Institute of Theoretical Astronomy in Cambridge, which at that time was being run by Fred Hoyle. We touched upon Fred last night, and if I have time I'll tell you a story about how he got into the viruses from space. But the point I want to make is that at that time I was very enthusiastic about the subject now called astrobiology. Then it was called exobiology, the possibility of life beyond Earth. And one might as well have professed an interest in looking for fairies. It was considered obvious that we are alone in the universe, that Earth is the only planet with life. Francis Crick summed it up very well. Life seems almost a miracle, he said, so many other conditions necessary for it to get going. And Jacques Monod, in his book Chance and Necessity, said, man at last knows, somewhat sexistly, man at last knows that he is alone in the unfeeling immensity of the universe out of which he emerged only by chance. And you can see from his face, this coincided with a period of Gallic nihilism. And so I think the prevailing mood was that we live in a hopeless, pointless universe, that humanity is doomed, and we're just a bizarre accident on one planet in the universe. Well, then fast forward about 20 years, and Christian de Duve was not only able to say that life is almost bound to arise on planets where physical conditions resemble Earth, he had this ringing phrase, life is a cosmic imperative. So somewhere between this we are alone and the universe is teeming with life lies the truth. How do we make progress with this? Now there are two arguments, both of which were touched upon last night, which are made in favour of the teeming with life hypothesis. The first of these is, well, the universe is just absolutely so huge, there's got to be life, there must be life out there somewhere. I think Larry Niven actually pretty much said that last night. All right, Stephen Hawking said to my mathematical brain, well, I think I've got a mathematical brain too, maybe not as good as Stephen's, but I know how to do the numbers. And within a Hubble volume, there are about 10 to the 22 planets. So what is the probability that there's going to be life on at least one other planet? Well, this is where one likes to bring in the Drake equation. There's Frank standing in front of his equation. And the terms in that equation will probably be familiar to most of the people here. And they sort of divide up into astronomical terms, the first three, then biological terms, the next two, and then sociological terms. When Frank wrote that equation down, and I was a great fan of SETI and Frank back in those bleak early days when it was like looking for fairies, those numbers, almost none of those numbers were known, but now the ones in the green box are actually fairly well understood, and in particular because of efforts in extrasolar planet hunting, Kepler and other satellites and ground-based missions. There's now a catalogue of several thousand candidate planets, of which some are clearly going to be Earth-like, many more to come. And so estimates appear all the time, and this is a classic example. A news report 2 or 3 years ago, billions of Earth-like planets in our galaxy alone, and we're very used to these sorts of statements. Now, unfortunately, the media and some scientists who should know better will often conflate habitable with inhabited. The fact that a planet is Earth-like and habitable by Earth life does not mean it is inhabited. There is a huge difference, and the reason is that for a habitable planet to become inhabited, non-life has to turn into life on that planet. It's an obvious statement. A planet will only be inhabited if life emerges on it, whatever that process was. Now, that is the term F sub L in the Drake equation. So we go all the way up, 1, 2, 3, the numbers are good, we hit F sub L. What are we to put in for that? F sub L is the fraction of Earth-like planets on which life actually emerges, and I think Frank takes 10% as his guess. So where does that number come from? And I think a lot of people, maybe people in this room, would think, well, that sounds about right. This is the problem of life's origin. And I think it was well expressed last night by Geoffrey Landis, who made a point that Darwin made 150 years ago. Darwin gave us this wonderful account of how life on Earth has evolved over billions of years from simple microbes to the richness and complexity of the biosphere we see today. But he pointedly left out of account how life got going in the first place. It is mere rubbish, he said, thinking at present of the origin of life. One might as well think about the origin of matter. Well, I'm pleased to say that we physicists have now solved the problem of the origin of matter, but we are very far indeed from solving the problem of the origin of life. We're just almost as ignorant today about how life began as in Darwin's day. Now, let me make an obvious point, which is a point actually Geoffrey Landis made last night, but I want to make it again because it's amazing how often this gets overlooked. If you don't know the process whereby non-life turned into life, you can't estimate the odds. And time and again, journalists will say to me, well, how likely is it that we're going to find life beyond Earth in my lifetime, or in the next 20 years, or the next 100 years or something? And it's not sufficient to say, well, I don't know. The point is nobody knows, because we don't even know how to go about doing the calculation. Now contrast this with the things that most people fret about in the Drake equation. It's often said, it's very likely that there's microbial life all across the universe, but intelligent life will be very rare. That the probability of going from microbes to telescope-building beings is very low. And that's probably true. However, at least we know the process that does it. It's called Darwinian evolution. We don't yet know how to do the calculation. If you have a planet with microbes, come back 3 billion years later, will you find radio telescopes? We don't know how to do that calculation, but at least we know the mechanism that did it. We don't know the mechanism that turned non-life into life, and so we have no idea how to work out the odds. Nevertheless, we still see statements, as Mary Wojtek, with all the other planets around, all the other stars, it's impossible to imagine that life wouldn't have arisen somewhere else. Impossible? I can imagine it. I can very easily imagine it with my inferior mathematical brain. Here's Darwin's warm little pond. He wouldn't be drawn on how life began, but he did conjecture about this famous warm little pond. And so let's imagine something like a warm little pond, and let's imagine chemical processes taking place. So he gave the idea that over a period of time and with some sort of energy source, more and more complex molecules would accumulate until something eventually crawls out of this pond. And so we need to come up with some idea of how to quantify the processes that would have taken place. We don't know that because we don't know how those processes work.